Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to some of the solved problems 3.3.9 solved problems. In the first problem is if a equal to minus 2 1 0 3 4 minus 5 and b equal to 1 2 4 3 minus 1 5, then find a plus b dash. This is our given problem. In this problem, we have to given two matrices and then find a plus b dash value. Then first solution is given matrices are capital A equal to minus 2 1 0 3 4 minus 5 and b equal to 1 2 4 3 minus 1 5. This is b. We have to find a plus b dash. For that, first find out b dash value. B dash equal to 1 4 minus 1 2 3 5. Then now a plus b dash equal to, first matrix A is minus 2 1 0 3 4 minus 5 plus b dash value is 1 4 minus 1 2 3 5. Then that is equal to minus 2 plus 1 minus 1 1 plus 4 5 0 plus minus 1 minus 1 3 plus 2 5 4 plus 3 7 minus 5 plus 5 0. This is a plus b dash value. Next we will go to second problem in the same solved problems. Next, second problem. The problem is if a equal to minus 1 2 0 1, then find a dash. Do a and a dash commute with respect to multiplication of matrices? This is our given problem. In this problem, we have to given a 2 by 2 matrices and find a dash value, and also ask one question, that is, do a and a dash are commute with respect to matrices multiplication. Commute means if a comma a dash are commute, a dash equal to a dash a. These two values are equal to each other, then a dash and or commute with respect to multiplication of matrices. For that, directly we ask a dash value, and also we can find a dash a. For this, a dash commute with respect to multiplication of matrices. For that, first write down the given matrix is a equal to minus 1 2 0 1. This is matrix A. Next we can find a dash equal to minus 1 0 2 1. This is a dash value. Next we have to find a dash. A into a dash equal to, first matrix A is minus 1 2 0 1 into a dash value is minus 1 0 2 1. This is a dash value, that is equal to, first row first column, minus 1 into minus 1 plus 1 plus 2 into 2 4, 0 plus 2 minus 0 plus 2 0 plus 1, that is equal to 5 2 2 1. This is a dash value. Next we automatically find a dash a, that means minus 1 0 2 1 into minus 1 2 0 1, that is equal to, first row first column, 1 plus 0 minus 2 plus 0 minus 2 plus 0, 4 plus 1, that is equal to 1 minus 2 minus 2, 5. This is a dash a value. But by observing these two matrices, therefore a dash is not equal to a dash a. Then we said that a and a dash are not commute with respect to multiplication of matrices. Therefore a and a dash are not commute with respect to multiplication of matrices. Multiplication of matrices. This is our second problem. Next we will go to third problem in the same solved problems. This is our third problem. Problem number 3 is if a equal to 0, 4, minus 2, minus 4, 0, 8, 2, minus 8x is a skew symmetric matrix, then find the value of x. This is our given problem. In this problem we have to given a matrix in that one element x is unknown value, then we will find that unknown value. By finding this, there are so many methods. One of the simplest method is given capital A, matrix A equal to, first write down 0, 4, minus 2, minus 4, 0, 8, 2, minus 8x. This is a matrix A. Already we know that A is a skew symmetric matrix. Skew symmetric matrix means in a skew symmetric matrix, ith element of a matrix A is same as the negative of jth element. And also we indirectly understand by the definition, in skew symmetric matrix the diagonal elements are equal to each other. By using that, if A is a skew symmetric matrix, A is a skew symmetric matrix, and also we know that A has all diagonal elements are equal. Elements are equal to 0. Because A is a skew symmetric matrix, then x equal to 0. X is one of the diagonal element, then x it becomes 0. This is one method. And the second method is given, first write down the same given matrix A equal to 0, 4, minus 2, minus 4, 0, 8, 2, minus 8x. This is A. Given know that A is a skew symmetric matrix. Already we know A is a skew symmetric matrix. A is a skew symmetric matrix. Then we will understand that means A dash equal to minus A. A dash equal to minus A. For that, first we can find A dash, then equate this equation, then we easily find x value. Then A dash equal to 0, minus 4, 2, 4, 0, 8, minus 2, 8, 1 minute, here minus 8, minus 2, 8, x. This is A dash value. Substitute this in this equation. A dash equal to minus A. That means A dash value is 0, minus 4, 2, 4 0 minus 8 minus 2 8x is equal to minus of a value is 0 4 minus 2 minus 4 0 8 2 minus 8x. Then by using these, then this matrix is equal to 0 minus 4 plus 2 by multiplying with minus 4 0 minus 8 minus 2 8 minus x. These two matrices are here equal. Then if any two matrices are equal to each other, then their corresponding elements are also equal. Then by using that condition, we understand that x equal to minus x. From this, x plus x equal to 0. Then x plus x value 2x equal to 0. Then by calculation x equal to 0. This is another method. If any of the method is we can use in the examination. Next we will go to fourth problem. This is problem number 4. The problem is, for any n by n matrix A, prove that A can be uniquely expressed as a sum of symmetric matrix and a skew symmetric matrix. This is our given problem. In this problem we have A is a square matrix of order n, and this A can be uniquely expressed as a sum of symmetric matrix and a skew symmetric matrix. Then go to solution. First, given A is a n by n matrix, we know if A is a square matrix of order n, then we, by the definition of skew symmetric and symmetric matrices, A plus A dash is a symmetric matrix. And also A minus A dash is a skew symmetric matrix. A plus A dash is a skew symmetric matrix. A minus A dash is a skew symmetric matrix. These two statements are taken from the definitions of symmetric and skew symmetric matrices. Then we have to show the sum of the symmetric and by that symmetric matrix and skew symmetric matrices definition. A plus A dash and A minus A dash are symmetric and skew symmetric matrices. Then by although already we know if A is a symmetric or skew symmetric matrix, then K is also a symmetric or skew symmetric matrix. Then by using that statement, we take that A plus A dash by 2 is a symmetric matrix, and A minus A dash by 2 is a skew symmetric matrix. Is a skew symmetric matrix. Then let it be matrices B and this will be C. In problem, we expressed as sum of the two symmetric and skew symmetric matrices. Then by using this, here B is a symmetric matrix and C is a skew symmetric matrix. Then we can write A equal to B plus C, because B is A plus A dash by 2 plus C means A minus A dash by 2. By solving these two addition, we can have A value. Then this A can be easily write down the sum of the symmetric and skew symmetric matrices. This is our fourth problem solution.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.